Welcome everybody to Training Tuesday. We're going to have a little bit different attendance here for getting started here. I'm sitting here with my buddy Drew Roby, filling in for Miss Heidi. So we'd like to welcome everybody for coming in today. And as you know, my name is Chuck Hoke. I'm the National Training Manager for Dayton Superior. Right from the get-go, we will be getting started here with the presentation. This presentation is intended for training purposes only. For any technical specifications or products mentioned in this training, please refer to www.daytonsuperior.com. So let's ask, who is Dayton Superior? Well, we are the leading provider for engineered solutions in the concrete industry. We are a leader in the manufacturing and application of accessories, chemicals, forming, engineering for all of those products, and obviously training. You can find any of that information here at DaytonSuperior.com. And a lot of other information that we'll talk about a little bit later on for resources, etc. That's all available on that website. So today we're going to talk a little bit about interior bridge decks. Interior bridge deck forming realistically has decreased considerably over the years as we start to see more and more contractors use SIP decking and other means such as concrete plank for forming up their interiors. Well, that trend is starting to change a little bit. We're seeing that a lot of states are going back to wanting removable wood form so they can actually inspect the bottom side of the bridge decks. We see a lot more building construction in lieu of using SIP decking. They're using removable wood form for forming up the interior bays between the structural steel beams. So, and realistically, forming an interior bridge deck is the same process as you would do in a commercial building application. So with that being said, when we look at how to do a bridge deck, for example, and this can also pertain to a commercial structure, but you want to actually look at developing the estimate here. You can call your Dayton Superior sales rep to actually get you a quotation or an estimate on how to calculate the number of brackets and hangers that you're going to need. And with this program here, that what we're going to show you is the steps that you would have to go through to get the number of interior hangers that would be required. Excuse me. So what we're looking at, when you get a set of plans, yeah, there's usually a lot of plans, a lot of different pages. Looking at a job here this morning, had 2,700 pages to the project. I needed a grand total of 4 pages out of the whole set of plans to do a bridge takeoff for the customer. So it realistically, you only need a very few number of pages to actually accommodate the bridge takeoff. So one of the main pages you will find here, and something that we will show you here is, I apologize for that. One of the main things that you will find here is the section view of the deck. The section view, which let me go back a page again. The section deck typically is when you're looking at from the end of the deck moving forward. With that being said, you would actually need also the plan view of the deck. Now with this view here, you're looking at it from above the deck, above the platform, whatever, floor slab, looking downward on it. So what you're going to see is the actual area of the that the bridge deck is going to encompass. So we're looking at from abutment to abutment. This gives you an overall length of the bridge here. And one of the other things you also will see is down here on the bottom, I will highlight right in this area here. You will see this area here actually is the detail for the bridge beam itself. Whether it's concrete or steel, typically they will have details for the beams listed. Steel gets a little more complicated than a precast type structure. So you have to make sure that you're, depending on what part of the country you're in, and whether it's not steel being used or concrete being used, you have to pay close attention to that. So with that, you're going to have the overall length of the bridge here in this picture. You're going to have also, as I highlighted earlier, the details for the beam. And usually when you start to do your overhang spacing and the girder details here come into play here. And what you're primarily looking at, you're looking at the top beam flanges. And that's the top layer, the top level of the beam. And what you're going to be looking at is how wide that beam actually is. Now, a lot of times beams can actually change widths within mid-structure and then go back down again too. So you'll find that it's not always a consistent number across. So a lot of times, what I like to do is I will take the smallest number. So if you have like on this bridge here, it says you have an 18-inch or a 14-inch beam at the lowest end. The next plate I want to say is like a 20-inch. So you're going to look at those numbers here and say, well, I'm going to calculate everything on the 14-inch as that's going to be my worst case scenario. When you're looking at girder spacing and everything, you're going to be looking at how spacing from center of beam to center of beam. And that figure you're going to get right here on that section view. Like I said, we're only going to have a couple of drawings that we actually have to pay attention to on this. So we're going to kind of keep going back and forth to get all the numbers that we have to have for it. So here we have the section view, which actually is going to give us the spec girder spacing, center to center. And on this view, we're also going to get the deck thickness. With this deck thickness on this view here, this one page in itself has a ton of information on it. You're going to be looking at deck thicknesses. You're going to be looking at deck thicknesses over the beam, which can be different because of what they call the haunch, which the haunch is something that is built into every structure to actually keep the bridge deck at a constant thickness. So you will get a bridge deck thickness that will say, let's say it's 10 inches. On one beam, you could have 2 inches of haunch. On another beam, you can have 5 inches of haunch, depending on the slope of the deck, etc., and how the beams were positioned. The haunch actually helps the contractor, so he's not putting an extra 5 inches or 3 inches of concrete in that deck to actually make the whole deck level. So you're also going to get any of the parapet designs here for the overhang bracket, for the overhang. And the dimensions at the overhang will also be on here. Overhang width will be on here. the bridge width, the overall width out to out. Now, why is that important? Well, for the interiors, it's not all that important. For the exterior overhang, which we will talk about next week, it will be extremely important. So we're also going to see the deck thicknesses, basically, as I talked about, for what we call the haunch. You're also going to see the deck thicknesses, coverages, rebar size, etc., all listed on this section view of the bridge deck. And what that's going to do is basically help you when we do the bar support takeoff, for basically coming up with all the accessories that you can actually put together in a quotation package. So here you're going to get any of the rebar sizes, and obviously rebar sizes is all pertaining to CRSI standards, 3 bar through 18, etc. Both support longitudinal and transverse. Longitudinal being bars that typically run across the bridge deck. Transverse is the ones that run parallel to the beams. So you're going to get things like top bar clearance and all that other information, and bottom bar clearance, etc., all on these drawings. And all the obviously the rebar sizes themselves. So from typical deck section, we can actually now start. Let's take a look at starting to determine the center to center. So center to center typically means from center of beam to center of beam. Remember, we're not rocket scientists here. We're going to try to keep this as simple as we can. So when we're dealing with center to center of beams, we have a spacing here 9 foot 8 inches from center to center. And we get that from this dimension right in here. Okay. So from there, 9 foot 8 inches. And from our framing plan, where we looked at the beam, and we see that the top flange is 14 inches and 22 inches wide. Okay. And like I said before, we're going to take our worst case scenario, which means we're going to use the smallest beam width that we have, because that means we have more concrete that has to be supported by the bridge hanger. When we get to when we get to the 22-inch side, because that top beam flange is wider, that beam flange is now going to support more of the concrete than the 14-inch, obviously. So you got basically another 8 inches of concrete, so 4 inches on each side here that are being supported on that 22-inch side. But we aren't going to worry about that. We're going to take that and say, well, I'm only going to take into consideration my worst case scenario. So we have 9 foot 8 inches minus less 1 foot 2 inches means I have a clear span of 8 foot 6 inches, or 120 or 102 inches clear span for this example. And we know from looking at the drawings that the bridge deck for this project, the concrete deck thickness is a constant 10 inches thick. So we know that we have 102 inches and it's 10 inches thick. Well, the first thing we're going to want to do is let's look at supporting our joist size. So our joist charts. First thing I would recommend for all of us to do is get a hold of a bridge deck handbook put out by Dayton Superior. I've been in this business for 50 years, almost 50 years, and it is still one of the best pieces of literature that's available in the marketplace. And all those tables and drawings in the front of the book come in handy because each one of them pertains to a different process. And inside the book, we actually show you our joist spacing. So here we're showing our joist spacing We come down here to 10 inches on the concrete thickness. And depending on how we're running our plywood, either face grain runs perpendicular to the joist or runs parallel to the joist. Worst case scenario is it runs parallel. So with that being said, my worst case scenario is 15 inches. That's my 15 inches spacing that typically I'm going to have space on a 2x material. So with a 2x material, you've got a multitude of joists that you can actually have. Guys, like I said, I like to keep it simple. So what I would recommend is only using 3 different ones: 12-inch centers, 16-inch centers, or 24-inch centers. And perfectly honest with you, I don't like 24 inches because it leaves too much of a potential for the plywood to actually sag when you load it with concrete, because the joists are spaced too far apart. 16 inches is okay. 12-inch actually works really well if you're using 2x4s. Now, I'm kind of old school. I like using 4x4s because they don't roll over. Where a 2x4 or 2x6 can roll over. So I would use a 4x4. Plus the fact you don't have to nail it as often as a 2x4. So with that being said, we have 8 foot center to center clear span, let's say. And we have in this one here, we have 6 foot 6 inches on my clear span. From there, you go to your ledger booklet. You go to your joist centers. I always, like I said, I like 12 inches, joist center to center. And it tells me that the maximum distance I can space those with a 2x4 joist is roughly 4 foot from the ledgers, from ledger to ledger. Now, if I use a 4x4, I could go to 66 inches. But let me tell you, right now, I will tell you that we recommend that the farthest you can space any of the hangers typically is 48 inches or 4 foot on center. So I always resort back to the 4 foot on center. I always double check. If it's under the 4 foot, I look where I can change it. And if I have something I can do by just changing a lumber grade, I can actually make that change to actually increase that dimension. So now the ledgers that we have that we're going to span across from beam to beam that actually are going to hold those joists with the plywood and actually support the concrete deck. We actually have a spacing table in the handbook that will enable you to actually go to what you are looking for your ledger center to center. So usually those are double 2x, and they can typically be a 2x4, 2x6s, 2x8s, 2x10s, or 2x12s. 8 foot 6 inches, I can tell you right now, for a standard spacing, is going to probably be a 2x at the 10-inch deck thickness. It's going to be a 2x12. Typically with a 2x10, you can go up to about 100 inches with a 10-inch deck. That's just one of those things that you learn because of repetitive hammering every time you do one of these jobs. It's just, you remember it from time to time. So here, what I would looking at doing here, my ledgers, typically I would typically look at spacing them, and they start at 2 foot and go about approximately every 3 inches all the way down through. So when you get through the book, the book actually will actually show that you can have the ledgers out at a maximum here of roughly, I want to say here on, you can do with, if you had a 32-inch ledger on a 10-inch deck, right here, your maximum would be 96 inches, and you're using 2x10s. So for 106 inch, you're going to go with 2x12s here. This dimension right here. So we know what lumber we can use now going through here. Now, if you look at where it says where it comes out to ledger spacing at 4 foot in the spacing, and I apologize, I didn't put that chart in the book in the presentation. But if you're looking at this, you're basically going to have, if you want to space at 4 foot on center, because your joist can go 4 foot in length, so you might as well see if you can maximize the coverages. So here you have 183 pounds per square foot of pressure coming down here. So we're going to say 6 foot 6 inches divided by 2, because you have 2 hangers, 1 on each side. If you go 4 foot on center, you're going to have 2,383 pounds of pressure per hanger that you're going to need to support. Or if you go 5 foot 4 inches, which is sometimes a common number, I don't like to use that because usually that requires a different spacing on the outside of the overhang bracket with the bracket. So I always kind of like to maintain, when I'm doing a deck, I'm going to calculate my exterior and my interior together and piece that, make everything uniform going across the deck, so that dimensions do not change from outside to inside. If they do, it's usually going to be an outside dimension of, say, 2 foot, an interior dimension of 4 foot on center. So I would actually have alternating hangers on the bridge beam themselves. So this will actually determine right here, this number, the weight of pressure that you've got to have on the hanger, what hanger you're going to use. So 2,383 pounds at 3 foot 3 inches on center, if that's what you wanted to go with your overhang brackets and everything, would typically require a C60 type hanger, either a type 2, type 3, or type 7. Now, those 3 hangers all have different haunch values already built into them. The type 2 is 1 inch, type 3 is 1.5 inches, and a type 7 is a 2-inch built in. But you're looking at the capacity is only 2,300 pounds with this hanger. And that's what the deciding factor is going to be. Now, if I went 5 foot 4 inches, or let's say I was going to go 4 foot on center, which is what I would typically do, I would cut that dimension 5 foot 4 down to 448 inches, because that would be consistent with the possibility of using a 4 foot overhang bracket. I could go with a C41 hanger at 4,500 pound safe working load and use coil with C41 and the C41A to run across the bridge deck. It would make it uniform across the deck and make it much easier to form up for the contractor. And our engineers can typically help you with this spacing and design practices within this overhang bracket to actually make it simpler to actually accommodate. Now, haunches, the one nice thing about using this type of a hanger, there is no criteria for haunches. The haunches can be whatever they need to be. I mean, I have done bridges like this with everything from a 2-inch haunch to a 16-inch haunch, all using this type of a hanger. So there are certain hangers within the portfolio that Dayton offers for hangers that actually accommodate different situations within the haunch and the spacing from beam center to center. That all comes out here within the bridge information sheet. The bridge information sheet here is available online. If you go to DaytonSuperior.com and call in bridge deck information sheet, this form will come up electronically. You can have that filled out and we can actually run the calculations for you for your bridge deck. We will talk next week about the engineering sheets, how to read those engineering sheets once they come about, and that'll actually give you some guidance. Hopefully we'll put everything here that we're looking at and rhyme, make a rhyme and reason out of what we are talking about. So with that, I'd like to say once again, visit our DaytonSuperior.com website. Where there you'll find any of the technical data sheets, handbooks available. You'll also get any regional maps available for all the sales force across the country, so you can actually see who your salesman is, how to get a hold of them. His cell phone numbers are all listed on that book. And if you have any questions, please feel free to contact us at DaytonSuperior.com. And thank you very much. If anybody has any questions, please feel free to put them up now and we'll go from there. Thank you, Tracy. All right, well, it looks like we don't have any classes. So I'd like to say thank you very much and have a great day, everyone. Thank you.
Thanks, John.